This video will take a look at the definition of a function and also how to evaluate functions. The definition of a function is a correspondence between one set called the domain and another set called the range, such that each member of the domain corresponds to exactly one member of the range. Alright, so what this really means is that we have a domain with some numbers. We also have another set of numbers called the range. And really the domain are x values and the range are y values. Each member in the domain, each number there, must correspond to only one number in the range. That's the idea. I have two examples written down. Let's say in this first example that the domain is -3, 0, and 4, and the range is 1, 5, and -2. The arrows represent the correspondence. So -3 corresponds to 5, 0 corresponds to 1, and 4 corresponds to -2. You can see that each number here in the domain points to one number on the right side in the range. So this would be an example of a function. We could write down points for this correspondence as well. The points would be -3, 5. The next point would be 0, 1, and then 4, -2. You can see that these are the numbers in the domain, and these are x values, and these other numbers are the numbers in the range, which are y values. Now in the second example, we can see that we've got 4 numbers in the domain, numbers in the range. In this example, it is not a function because 5 corresponds to 2 numbers. The definition says that each number in the domain can only point to one number. So because of that 5, we do not have a function here. The points are 1, 7, -4, -1/2, 3, 4, 5, 4, and also 5, 0. Now if you notice, these x values repeat here with the 5. So another way we could look at a function is this. A function has no repeating x values. Notice that this was not a function in this example because the x values repeat. If you look at these x values in the previous example, they're all different. Let's move on and take a look at how to evaluate a function. Function evaluation. Now suppose that we have the following function f of x equals 4x squared minus 3x plus 1. And on part A, we need to find f of 0. Now you see that 0 is where x is up here in the function name. So what we'll do to find f of 0, we'll take the number 0 and plug it in for x. So when we plug it in for x, we have 4 times 0 squared minus 3 times 0 plus 1. This turns out to be 0. This is 0. This is 1. So the answer would be 1. And this is called the output. The output's always a y value. The number we plugged in is called the input, and that's always an x value. Let's do another one, part B. Find f of 2. Very similar idea. I need to plug in 2 for x. We'll use the same function up here at the top as we did earlier. 4 times 2 squared minus 3 times 2 plus 1. This will give us 4 when I square the 2. 4 times 4 is 16. Minus 6 plus 1. 16 minus 6 plus 1 is 11. So 11 will be the output. Again, that's a y value always. And this was the input of 2. Input is always an x value. Now for the next part, we need to find f of x minus 1. So just like before, we plugged in a number. Now we're going to plug in x minus 1. So it'll look like this. F of x minus 1 will equal 4 times x minus 1 squared minus 3 times x minus 1 plus 1. What we'll need to do is get rid of the parentheses. So x minus 1 squared is the same thing as x minus 1 times x minus 1. Next, we'll use FOIL. The FOIL method will multiply two binomials together. So I'm going to keep the 4 in front and do a little FOIL here. X times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And then finally, negative 1 times negative 1 is positive 1. I'm going to copy everything else down here at the end. After we FOIL, we need to combine like terms. So we can combine these x's together here in the middle, and that'll give us minus 2x. Okay, the next step is to distribute the 4 to each one of these terms. Also, we'll distribute the negative 3. So multiplying 4, it's 4x squared minus 8x plus 4. Distributing the negative 3, we get negative 3x plus 3, and then plus 1. Now, lastly, we need to combine like terms. So if we look here, we only have one term that has an x squared, so I'll write that first. Then I need to combine these two terms together, the x's. That'll be negative 11x. And then lastly, we'll combine these numbers together, and that is positive 8. So this is the output for this particular problem, and our input again was x minus 1. That's a look at how to evaluate a function. Basically what you're doing is plugging in a number and simplifying, or if you have an expression, a couple terms to plug in, you might use FOIL and the distributive property.